Topic of this presentation is MS Interpreter for EI accurate mass data, correlating structure to mass to charge. It includes both a video and a handout. And the handout often has additional information that's not found in the video, so you might want to check it out also. On my website, you can see the full course on the NIST 26 with the newly integrated deconvolution library searching for EI GCMS and LC MSMS data. There's lots of help built into the software in using MS Interpreter, and I've listed some of the ways to access it below. I will not go through that demonstrating in the software, but I'll leave it as an exercise for you to try. Also, there's a user's manual that goes along with the software that has a lot of useful information. I also have other training videos and handouts on MS Interpreter. They're still very useful, especially for the new users, and you can see some of the links below. This one's particularly good here, but even in my course on the general use of the software within the NIST software from previous versions, you'll see that it has MS Interpreter sessions plus many other useful resources, but it's split into videos and associated handouts. You can send any result in the chromatogram list to MS Interpreter. Below, I've taken a process of a file. It's an accurate mass file, and you can take anything and send it to MS Interpreter by selecting what you want and then say send to MS Interpreter. So let's go to the software and demonstrate that. So again, we have this accurate mass file. I'm going to pick this peak here that it thinks is decanoic ethyl ester, and if you look at the butterfly plot, it looks like a good fit. And it also has the green dot on the peak that we're processing. So on the bottom, if you right click and say send to MS Interpreter, it opens the MS Interpreter window. In the bottom is the accurate mass spectrum of the unknown. And in the top, it's taken the structure from the library that was in the bottom. So it's kind of paired them together. And when you click on it, like the molecular ion, if you look up here, that's the parent ion. It has an error of 0.6 part per million, and it calculates all the elemental formula over here. And of course, you can click on any ion in the spectrum that's black, and it tries to explain it. But there's a lot more explanation in my MS Interpreter software, but that's pretty much the basics of doing it. It's pretty easy. So I'm going to close this window. If you go up here, normally when you right click in something, it'll say send to, but it doesn't have any options for either the upper or the lower. But if you go to the upper text and say send to, you can send it to MS Interpreter. But when you do, it sends the mass spec, the accurate mass spectrum to MS Interpreter with no structure. If you click on the bottom text and say send to MS Interpreter, it sends the spectrum and the structure for the library entry. It's not in accurate mass. That's just if you want to understand how your compound fragments that's in the library. So if you really want the accurate mass data, you need to click on the bottom and send that to MS Interpreter, this bottom plot. And that's the most useful information that I think you can use for processing accurate mass data out of this window. Another thing you might like to do is sending an unknown accurate mass spectrum to Mass Spec Interpreter and adding the structure of the identified component from the lib search window, not from the chromatogram window, but the lib search window. So use this approach if the best hit in the chromatogram is not the best candidate. Compare a hit with the lower match factor, but maybe something you think might be more likely. So we'll go through that process. It's somewhat similar, but I'll go again to the software to demonstrate that. So you go to the software, but first we have to select what we want. We'll select the same compound with the same results, and we'll right click and say library search. And I've got it set up for identity search. You can see at the bottom it did an EI normal for both the display and for the type of search. At the top you can see it found 50 spectra, and it thinks decanoic acid ethyl ester is the best hit. If we go down and select the second best hit, let's say we wanted to see how that might fragment, we'll right click on it and say copy selected, I think we want copy structure to clipboard. So it's going to put it in the Windows clipboard. So it'll store it there. So we have that one there. Then we'll go to the top where we have our accurate mass spectrum, and we'll say send to MS Interpreter. You can see there's no structure here now, but if we click in the box where there should be a structure and say edit, paste, or we can do a Control+V off the keyboard. And now we have our new spectrum, our accurate mass spectrum on the bottom and our proposed structure on the top. And like you'd expect here, just branching at the end doesn't affect much. Maybe it might change this part. You can circle within MS Interpreter, so you might think it might have a bigger 43. So maybe if you compared it, it might be a little different. But in general, it probably would be difficult to tell if it was the original or the branched material. So the last approach I'd like to show you is if you have a user proposed structure for accurate mass spectrum, I want to show you how to take your structure and put it with the accurate mass to see if it fits with the MS Interpreter fragmentation pattern. And it's pretty much outlined in this process here, but I think I'll show it to you in the software instead. You can always come back and review this. Go to the software. I'm going to take this search as the structure from this search to show how I can modify it so I don't have to draw it from scratch. It's much more efficient if it's just a slight change to start with a structure. So I'll right click on that and say send to default structure editor. And on my system, it's ChemSketch. I don't particularly like this form of it, so I think I'll change it to another format. So I'll go up to Tools and say Options, Set Drawing Style. And I'm going to change it to ACS, which I like better. So I have that structure there, and I want to modify it. So I really just want to take one of the methyl groups off. So I'll get rid of the one at the end. I don't want to change the molecular weight. I want the same overall molecular weight, and I'm going to put it there. And now I have my structure, and what I need to do is circle it and say Edit, Copy. Now it's in the Windows clipboard. Now I can go back to the MS and to the NIST search. I can send my accurate mass spectrum over to the MS Interpreter window. So send to MS Interpreter. Again, I have no structure. If I click in the box to make it active for the structure, I can go Edit, Paste, or Control+V off my keyboard, and I have the structure here. And again, it would probably be hard to tell if my proposed structure here was different from the best hit. There's just not much different. Maybe you might get a fragmentation there. I'm circling it just to see what it would be. It would be at 99. So you'd have to go back and confirm that 99 was bigger than this, but it doesn't really look like it is. So it's really hard to tell from any of these three structures which the best one is. You'd have to know the retention time or maybe a retention index to see which one it was in your sample. Probably retention index would be the best. So I hope you found this useful in your studies so that if you want to propose structures, you want to use the second best hit, you just want to confirm the accurate mass correlates with the structure that the chromatogram suggested. These three tools should allow you to do that. So I hope you find it useful. Good day.